In this tutorial video, we will be doing D. Remember, this is part 3 of the Euclidean geometry video. So, as I had promised, we will be proving that SP is parallel to TW. And we have already found the answers to A, B, and C on the previous video. If you want to see the solutions for these questions, you can check the link below. So let's do D and quickly go do a new question. So on D, we are asked to prove that SP is parallel to TW. To prove that SP is parallel to TW, we have to prove that, for example, let me choose two angles here. If we can prove that this angle here and these angles here, when added together, their sum is equal to 180 degrees. That would prove that SP and TW are parallel. There is also another way to prove this, and that is to look for corresponding angles. If we could find corresponding angles, we would also prove that these SP and TW are parallel. But then there's none of that. Another way that we could try to use would be to look at this angle again, but I'm just going to give it a different code now. We look at this angle and this angle here. These two angles are alternating angles. Yeah, like this. So you have this angle here, and then you have that angle there. So if we can prove that this angle is equal to that angle, then this line, let's say line 1, would be equal to this line, would be parallel to this line. Let's call it line 2. So they would be parallel to each other if we could prove that these two angles are equal. So here we're going to utilize the same line of reasoning so as to arrive to the conclusion that SP is parallel to TW. So let's try to check if we can find anything. Based on previous information, we knew that this was an equilateral triangle, which means that this side and this side and this side were all equal. And we also know that one of the characteristics of the equilateral triangle is that each angle is equal to 60 degrees on the interior angles of an equilateral triangle. So we know that this is 60 degrees. We need to find a way to say that this is also 60 degrees. In that way, we will then prove that SP is parallel to TW. So what can we do here? If you look at this diagram, you'll find that we have a triangle P, W, S. If you look at this triangle, I think it's fair to say that this angle is equal to that. It's 1, 2 is equal to that angle there. The reason W1 is equal to S2 is because of the turn-chord theorem. The turn-chord theorem is like this. So basically, you have this angle here. It's going to be equal to that angle there. So we're going to first say W1 is equal to S2 is equal to 60 degrees because of turn-chord theorem. Okay, since now W1 is equal to 60 degrees, we can then say since OP is equal to 60 degrees, therefore W1 is equal to P. These are angles, so I forgot to put that there. So W1 is equal to 60 degrees as well. I mean W1 is equal to P, which is equal to 60 degrees as well. So now that we've proven that this one is equal to that one, we can therefore say, therefore, SP is parallel to TW. The reason for that is because of alternating angles. W1 is equal to P, which is 60 degrees. Those are alternating angles of T, of SP and TW. And you know that if two angles are if two angles are equal and they are alternating, if two alternating angles are equal, then the lines that form those angles are parallel. The converse is also true. If two lines are parallel, then the angles, the alternating angles are also equal. Okay, now we're going to go to the next question.